All right, are we live? Yes. Opa. I'm not sure if people are seeing my screen. Let me try again. So, are you guys hearing me? Are you seeing my screen? All right, great. Thank you, Alavi. All right, so let's get started. Or should I wait a few minutes maybe? Are people still in the previous room? Previous chat? I will wait a minute. All right. Thank you, Alawi. For those already here, I put some polls up there. Well, some of them don't make sense answering yet before I start my talk, but some of them might. Hello, Jan. Hello, Dimitri. Seeing your messages in the chat. Hello, Fraser. That's how I pronounce your name, Fraser. Nice that you're all here. Great. All right, let's get started. So, hello everybody. Really nice that you're all here. I'm really excited to talk to you guys about debugging. So, well, let's start with who am I? So my name is Bart Sturm. I was born and raised in the Netherlands. These days I live in Brazil. I've worked for about 5 startups over my career so far. These days I'm co-founder and head of technology at a startup in Brazil called Tutor Mundi. What we do is help high school students and prep school students, although, well, those are our focus right now. We help them get into highly selective universities by providing them tutoring from those who already got in. From a technical perspective, it's mostly a chat app and, of course, built with Meteor. I'm sorry. I don't really have slides. I don't have many slides. I'm only using the slides for the code examples. So I'm just going to go back to my first slide for now, so that you guys don't have to keep looking at my static face. So we are at a Meteor conference, and as I said, my startup was built on top of Meteor. Meteor itself will not be my focus. I'm going to talk about debugging, which is a very broad topic, and it is going to be applicable to Meteor. It's going to be applicable to other languages, other framework, other technical contexts. That said, of course, I will give examples and such. Yeah, the examples I give will be from a Meteor context. Now I'm going to talk about, and I titled this talk, the stages of debugging. Why? Well, I think that we tend to do debugging in a rather intuitive way and a rather haphazard way. Each of us have our own intuition. We all have our own tools, and it's really nice that there's going to be 2 showcases later today or tomorrow, depending on your time zone, on this event of different tools that are made exactly for debugging. I will not be talking about tools so much as about the process of debugging. So as I said, I think debugging is something we tend to do in a rather haphazard, chaotic way. And you might say, well, that's the way it should be, right? Because debugging is exploration. But I'm not sure if that's the right way to think of it, because when I think of exploration, I think, oh, I'm going to a new city, and maybe I'm going to look at a map, or maybe I'm going to just walk in any random direction and just see whatever interests me. And it doesn't really matter where I end up, so long as something that interests me. And that's not what debugging is like. Debugging is very much, I mean, you have a very specific goal. You have already seen the bug, or at least you have evidence that it exists, and you are looking for that specific bug or the cause of that specific bug. By the way, when I talk about debugging, I'm going to talk just about the process of finding the bug. The process of fixing the bug is as much more similar to like development or I mean feature development or refactoring rather than debugging itself. So I think, anyway, my point is that we can benefit from a more systematic approach to debugging. That's my hypothesis anyway. And that doesn't mean that we should just disregard intuition. Intuition is very helpful, and it's many of the steps I'm going to outline use intuition and depend on intuition to work, but we're just going to be a bit more specific about what we ask of our intuition. Okay, so first I'm going to give a little bit of a background about this topic and why I'm talking about it. Then I will propose my own system, which are the stages of debugging that I'm talking about. And at the end, if there's time, I would still like to discuss some of the topics that you guys can raise in the chat, or actually mostly I will be looking at the polls at the end. So I put a few different questions there. You can leave questions there for me as well. I will be looking at those at the end if there is time, so we can have a bit more of a discussion. So why am I going to talk about debugging? Well, I think it's something that is not talked about a lot. And I actually realized this when I first entered my very first junior developer job. I realized some truth in what I had read before from people like Paul Graham, who wrote that programming consists of debugging, or that at least debugging is the core of programming. I'm not even sure I would go that far, but it's certainly the case that we spend a lot of our time debugging as programmers. And yet it's not emphasized at all. In my university course, I think I had one single class on it, and of course the odd comment here or there, but it's, well, programming resources, like there's a million websites where you can learn about loops and variables and functions, but very little about debugging. So I think mostly I'm doing this talk just to get a conversation started, just so we get in the habit of talking more about debugging. So what I did at that junior developer job, I decided if I couldn't rely that much on resources, I was just going to have to learn by doing. And more specifically, I was going to learn by doing and writing. So every day I would have one bug or another to solve. And as soon as I noticed it, I would go into the text editor and I would write down exactly what I noticed. I would write the steps I took to resolve the bug and what turned out to eventually be the cause once I discovered it. And this way I discovered, I learned a lot about different approaches to debugging. Now, over my career, I noticed that there are some difference, some patterns of differences in how novice developers develop compared to experienced ones. And it's not just, it's largely that experienced developers are just better at it. Of course, they have experience, they have a much more developed intuition. Juniors need to take a different approach because because there are so many more unknowns to them. There's so much more that they don't know yet. And one advantage that juniors have sometimes over some experienced ones, I think we experienced developers tend to sometimes make the mistake of relying only on our experience, even if we're approaching new frameworks or calling new APIs, etc. Juniors at least tend to be a bit more aware, as far as I've seen, of all the things that they don't know. So anyway, what is the system that I would like to propose? Well, step 0 is something that you don't really control. You find out about the bug. You learn that there is a problem. Maybe you're developing something and some apparently unrelated thing breaks, or maybe QA or support comes talk to you, or maybe you're analyzing the production bugs, the production logs, and find something strange, whatever. You learn about the bug and you go to step 1. I would argue step 1 should be to read the error messages. Now, most of us don't skip this. I think we really shouldn't skip this for those few who do. I've seen people who skip this, and I think I understand why. Partly, we developers we're really bad at error messages, I think, and so often like, I mean, undefined is not a function. It can mean a whole lot of different things, and not to single that out. I mean, there's across all technologies, I think, I don't think I've seen a single technology that really is very good at error messages. There's something else going on, and that is the stack trace which comes with the error messages, which is really intimidating, actually. But I think there's a simple antidote to that, because like the issue is, you see something go wrong, and you see a whole bunch of maybe 12 or 20 or 30 lines of information that you don't recognize. You see functions that you've never seen before in files you have no idea where to locate, and yeah, that's intimidating. It just leaves you more confused than when you started. But I think the correct antidote, or the most simple antidote to that, is to simply say, okay, it doesn't matter. I don't need to understand everything. What matters is that I look at the few pieces of the stack trace that actually come from my own code base and not from some Meteor or Node internals. And the rest I'm just going to ignore. I don't have to understand them. I'm just going to look at those bits that I do recognize, because those will tell you where to start. As an aside, if you're debugging with Cordova, for example, or any other web view, you should really make sure that you can see the client-side logs. This has probably saved me days of debugging on some occasions. You can just find out how to do so in the Meteor guide. If it's Android, you can do it in. You can see the logs in Chrome. If it's iOS, you can see them in Safari. All right, step 2 is reproduce the bug. It's also pretty straightforward. Sometimes it's hard. Usually it's easy, but sometimes it's hard. But the thing is, if we don't reproduce it, then we don't know if we fixed it. All right, step 3. I like to, as my third step, I like to test 2 hypotheses. Now, what I mean by that? We often have an intuition about what might be wrong. And And you should probably, like, often your intuition might be correct. So you don't want, so you just go right into the code and see if your intuition is correct. I think you don't want to skip this, even though it's not very systematic. You don't want to skip this, but you also don't want to keep doing it for too long either. I find in my personal experience that often my second hypothesis might be quite likely to be correct, but beyond that, I mean, the 10th or the 20th hypothesis is very unlikely to be correct in my experience. And so after this, I tend to continue a more, how do I say this? My more systematic approach. Step 4 is to make it quick to reproduce, because right now, we're probably going to be spending some more time with this bug, right? And we're going to cycle many times through reading code, changing code, and testing code. Reading code, changing code, and testing code. Maybe not, sometimes we are going to skip the change, but we're going to read and test code quite a lot. And so to make it faster to reproduce and faster to get insights from it, part of that is improve your visibility. And that's where those tools like DevTools evolved, or just console log and debuggers that let us set breakpoints, etc. Those increase our visibility. But it's also about running and editing our code faster. If it's in the client side and we are disabling hot code push, right now we should probably enable it. If your stack happens to support hot module replacement, which is brand new, then maybe you can enable that as well if you didn't yet. If it's CSS, you're probably already going to be doing inspect elements and edit your CSS right there in the browser. My favorite technique for JavaScript is you're probably going to have some idea of which function has a problem. And what I do is simply make it a global. So if you're seeing my slide here, very simple. I have this function here, add bugs. There's probably some bugs in that. And so I'm going to simply remove the const keyword from it so that we can, so that it becomes a global. And what I can do now is call it as many times as I want from the browser console. And that way I iterate very quickly. I can see what happens for many different inputs. Not only that, I can also override it very quickly. So here I'm overwriting the add bugs function to always return 25. Now actually my app, the front end of my app will also start using this overwritten version. So that is even faster than waiting for your app to pick up, for waiting for the whole hot code push process. If the bug is on the server, you can do pretty much the same thing on Meteor Shell with a few limitations. So in a new terminal window, you open, you just type Meteor Shell, and you have a REPL with which you interact with the server just the same way as the browser window. So there are two limitations to this. First is that is this error right here. If you're calling meteor.userid, for example, there are many other functions from Meteor that have to run in a specific Meteor context on the server. And so in those cases, you can't easily debug those using the REPL. And another one is that, as far as I know, the Meteor shell can only talk to your local server and not to a remote server. If either of those limit you, you could, what I tend to do in these cases is use, just export the function very quickly as a Meteor method. The advantage of this is you can now call it, again, just as many times as you like from the browser console and the REPL. The downside of this, you cannot easily edit your code. You have to, you keep having to go through your Meteor server restart, or in the case of a remote server, even a deploy to change your code every time. All right. The next step is where we are really going to locate the bug. Hopefully the exact line or even the exact statement or expression in JavaScript anyway that has the bug. And my favorite technique for this is binary search. And for those who don't know, the idea of binary search is that you take the whole search space and then you cut it in half, or you look halfway, and you check on which of the two sides is the thing you're looking for, in this case, the bug. And you take that side and you cut it in half again, etc., until you found exactly the place or the thing you're looking for, in this case, the bug. I'm going to give examples because this it's a very useful way to think about it, I think. But it tends to, it's quite, it depends a bit. Its success depends a lot on what you call exactly the search space. So, and of course, what you call half of it. A very simple example is with commits. Let's say my app was working just fine, and I pulled 20 commits from my coworker, and suddenly the app is broken. Now I can do a git checkout of the 10th commit and see if the app is broken. And if it works fine, I do a checkout of the 5th commit and check if the app is broken. And if it's fine, I can do a checkout of the 2nd or 3rd commit. And in this way, I have very quickly narrowed down the space in which the bug may be hiding. Another good way to slice it, so to speak, is to check, is it in the front end or in the back end? So let's say in Meteor, we have a button with an event listener, with a method. That is to say, the listener calls a method on the server, which updates the database. Now, I'm going to check what the method receives from the client. So in the very first line of the method, I log what the arguments are, and I'm going to see if that is what I expect it to be. And if it's what I expect it to be, assuming that's correct, then I know that the bug must be downstream from here, so on the server. And if it's not, then I know there must be a bug upstream, so on the client. Now, in many cases, it's a bit more conceptual, what you call the search space. So in those cases, I would say, like, it's not about counting lines of code exactly of your entire code base, but it's about eliminating the biggest unknowns. So you would say, so I would say one good one is simply, is the bug here or is it anywhere else? Like in the example that I showed you before, I assumed that the bug is in the function add bugs here, but there's probably the chance that the bug is actually happening somewhere else, and that this function just happens to be where it ends up breaking, but it's caused by a bug somewhere else. And so I'm going to try and prove whether or not the bug is in this function. And in that way I eliminate a big uncertainty and definitely a big waste of time that I eliminate this way by going down a big waste of time going down the wrong path. Some other ways to slice it that I find useful is, okay, is it the code or is it the test data? If you like to manually edit your user account or whatever, other things of the test data, in order to make things easier, sometimes that's the bug, you know. Another good one is the logic wrong or is the logic implemented wrong? Now, this is one I'm going to talk a bit more about in a minute. Now, this binary search tends to end up in one of three ends. You either find the bug, and you know how to solve it. So you discovered a line that has a typo, and you fix the typo, and you're done. It works. So that's great. Another one is you find the bug, but it seems to be outside of your code base. So maybe you trace the bug back to a single line of code of yours that calls a Lodash function, or that does, or an external API or something, and you start to worry that the bug might be in some tool that you're using. And a third option, unfortunately, it also happens that you don't find the bug. In a bit, I'm going to talk about the use, what happens when you're, if the problem seems to be in your use of a tool. First, I will talk about what happens if you don't find the bug. Probably it's because the bug is diffuse. The bug is, maybe the bug is in the logic and not in the program. And in other words, in this case, the bug is not really in the program. It's an error, just a reflection of an error in your understanding, an error in your mental model of the code. Now, there's many ways to debug your mental model, but it becomes a bit more psychological. I'm not a psychologist, so I can't go very deep on this one. But in my mind, there's basically two categories of tools we have to do this. Either you use your conscious mind or only your unconscious mind. And using your conscious mind basically means you're going to explain it. The point is that you cannot think of every part of your system, or even you cannot think of every relevant part of your system at the same time. And so you're going to make them explicit by putting it in words or in drawings somehow. Now, this can be by writing specifications or unit tests, actually, which are pretty useful for finding edge cases and cases that you haven't thought about. Or you can write make flow diagrams or another kind of visualization of the different states and flows through your program. Or you can just explain the program to a coworker, or you can pair on it. There's a famous story about this programmer who had a rubber duck on his desk, and anytime he hit a bug that he could not explain, that he couldn't understand, he would just explain the code line by line to his duck until he understood what was wrong. The programmer, not the duck. Now, my favorite rubber duck is Stack Overflow. Quite often, I write a question on Stack Overflow, and I never post it because before I finish, I have 5 different hypotheses about what might be wrong. And even if this doesn't happen, in the worst case, you can just post it, and you're going to find out if the duck can talk. Again, the point is that you're going to make a representation of your mental model of the program so that you can debug the mental model. Now, to use your unconscious mind, after you've done this, by the way, you should alternate between the two. To use your unconscious mind, just take a break, and those are very helpful. Just don't do it by checking Twitter. Don't do it by checking your favorite political news site. The point is that you should do something that does not engage your mind too much, because that way your subconscious mind has a chance of processing everything your conscious mind had been working on, and it also has a chance to, so to speak, knock on the door and have and bring its best ideas to the conscious mind, so that you have new ideas. And again, you want to alternate between these two approaches, ideally. And at some point, you're going to have new insights. At some point during this step, you're going to have new insights, and maybe you can fix it immediately, or hopefully you can at least go back to your cycle of testing, reading codes, maybe changing code, testing code, reading code, maybe changing code, testing code. The cycle which I think is behind all of debugging. Now, what is if your bug appears to be in an external system? Well, first, don't jump to the conclusion that the external system has a bug It is possible, of course, but most of the times that I started worrying about this, or most of the times that coworkers suggested to me that this might be the problem, it was not the problem usually. Now, of course, like Lodash has bugs. Of course, Meteor has bugs. Of course, Linux has bugs. Of course, that API that you're forced to use is maybe a piece of, sure. But the problem is that this particular bug that you're looking at right now is probably not caused by a bug in the in your dependency. And even if it is, I mean, before you come to the conclusion, you have to eliminate 2 other possible causes. Maybe you're not using the tool the way you think you are. Maybe there's something like maybe you're passing it parameters of the wrong type or whatever. Or maybe the tool was simply not designed to do what you are trying to do. And this can be quite subtle, actually. So what do you do in these cases? Well, you can read the docs, obviously. The docs, the documentation should shed some light on this. At some point, if the tool is not open source and you keep just banging your head against the wall and you can't find it, at some point it becomes worth just reading the entire documentation, or at least the meta documentation, the introduction to the documentation and stuff. Those tend to have some valuable information as well. So instead of reading the documentation of Lodash.map, for example, read the documentation or read the documentation of Lodash. But that's a last resort. Another good one is to test the tool directly outside of your context, and this is good to help to figure out if you're using the tool the way you think you are. So you can make you can just play with Lodash directly in the browser console, or you can call the API from Postman, or you can, in the case of Meteor, you can make a reproduction quite easily. Simply with this command, which we've all used before, Meteor creates test app, Meteor creates a test app, and you're going to make that test app do nothing but call that particular function or API that you're having a problem with. Now, the third option, and this is one great thing about using open source tools, is that you can look inside. And I'm going to tell you a little bit about how to do this with Meteor. Meteor is mostly made up of packages, just like the packages that are on Atmosphere. And you can edit those really easily. You can incorporate them into your own app and just use your own version. I'm going to give an example here from Auto Update, which is one of the core packages. You start by just taking the code and putting it into your own app. Now, I already have Meteor. I already have all of Meteor clones locally, so I'm just going to copy the code from my local version of Meteor straight into my own project. If you don't have it, honestly, in some cases, many of the packages are so small, you could even just copy it straight from the GitHub interface. Now, in your app, you want to make, in the root of your app, you want to make a packages folder, and in this folder, you want to make a folder with the name of the package, in this case, Auto Update, and in that folder, you want to put your code, the code from the original package, with all your modifications, and etc. And the great thing, this is one of those things about Meteor that just works. You see, assuming you were already using the Auto Update package, of course, you will just see the Meteor server restart. But before it says restarted, it will briefly show selecting package versions, which means that it actually picked up on the change. It realized that it now has different packages that it's going to use than before, or different versions of the packages. Now, if I said that's assuming you were already using this package. If not, then you're just going to Meteor add the package, just as that's another of those commands that you've called probably many times before if you've already worked with Meteor. And now you can edit the package. You can edit the code of this package exactly like your own code. You can add logs, you can comment stuff, you can You can just add things, and you can just save it, and you get hot code push, you get server restart, etc. All the good stuff. One thing that I found really useful when I had to mess in the auto update package was I found many things in there that are really useful to log. So I'm going to show some examples of those. Those are from the auto update version. There's one example from the reload package as well. So when my app Tutormundi was having trouble because a lot of my Cordova clients were not receiving hot code push, I used many of these functions and the subscription and values, etc. I analyzed those to discover what was going on, and that's how I realized that I was actually accidentally making it download huge files that I didn't mean to, and that's what was failing, because downloading the file was failing or timing out. Oops. Now, with plugins, it's kind of similar. The difference between plugins and packages is that plugins you don't put inside your app code, but you put in another folder on your computer, and then you add them. And you add that plugin in the same way as you normally add Cordova plugins, except instead of a version number, you put a relative path to the folder that contains your plugin. Or your local fork of the plugin, or whatever, your version of the plugin. And the relative path has to be relative to not your current working directory, but the current root of your app. Unfortunately, doing this is a lot slower than developing packages, simply because Cordova has to rebuild your whole app, and every time that you change something about the plugins. I don't know a solution to this, but if any of you have a solution to this, then I would love to hear about it. Please let me know in the chat. I'm sure there's many smart hackers that know things here that I don't. Now, if you're going to mess about in the Meteor code or in a lot of Meteor packages, or maybe in the command line, maybe you should just clone the whole Meteor project on onto your computer, and then you can call your local version of Meteor instead of your original installation of Meteor. So instead of the Meteor command, you're going to use the path, the relative path, this time from your working directory, the relative path to your to the meteor.bat file in your of your git clone of the Meteor folder, Meteor project, sorry. Again, when you look inside these tools, you're again going to be doing a constant cycle of reading code, changing code, and testing code, and reading code, and maybe changing code and testing. That cycle never really stops. That cycle is really the backbone of debugging, I would say, and maybe even of a lot other development. When we're doing this, or when we have done this, when we've looked inside or read the documentation or tested the tools outside of the original context, sometimes sometimes you realize what the bug was, and sometimes you might have to go back to the binary search step again, just like previously. Have to go back to the binary search step so that you can, but this time with new insights, but so that you can locate the bug inside your app. All right, those are the suggestions that I have for debugging. I'm really curious what insights you guys have. If I have, let me check if I have time to go into. I have a few minutes. Let me check what you guys said about debugging. Let me see. I'm looking at the polls now. All right, there is no answers in the polls yet. Let me check the chat. Do you guys have any questions, by the way? You can ask in the chat as well. Here, but no questions. Hi, Philippi. I'm going to give you guys a minute to ask any questions or to suggest any ideas, by the way. If you guys have any ideas for steps of debugging that that I left out, or great ideas that I forgot, or if you have any objections, any reasons why you think debugging in a slightly more systematic way is a bad idea, I would love to hear it as well. Thank you, Felipe. Felipe says, I'm loving your ideas and thinking. Thank you, Felipe. I'm very happy to hear it. Alawi asked, in a previous talk, I asked Zodern how he learned the internals of Meteor. Yes, in my case, I also just looked a lot inside the internals once I needed. Like it was always with a specific objective. Like I said, at one point, auto update wasn't working, or something else in my app wasn't working, and so I would just. Meteor has quite good code, actually. I would say in many places it's quite easy to pick up on how it's structured, although it's of course a big and complex framework. I would say it's quite relatively easy to read. I did often add a bunch of logs, just as Felipe is saying in the chat right now. And again, it's this cycle, right? It's a cycle of reading code but constantly testing it as well. I don't tend to use breakpoints much, but that's just one of those personal preferences. I do use a lot of console logs, just trying to figure out what is happening. Let me see what Adrian Lanning and Jan said. A great blog post. All right, I will think about it, Adrian. I hadn't thought of the idea of writing a blog post about this. Jan says that analyzing things more systematically is never a bad idea. The problem I often find is figuring out what system to use to generate the best outcome. Right, I agree, Jan. I struggled with this. I mean, I didn't originally think I would come up with a system exactly, or that was not how I thought of it. I mostly just was trying to learn how to debug better, and I was analyzing how I was debugging and analyzing the mistakes I was making. And I came up with several patterns of how I tended to debug and things I kept having to remind myself of. You guys probably recognize that there's always some things that we think we really should do, and that we regret not doing once we do them, but that's for some reason we never think of them at the right time. Anyway, just by analyzing a lot of these things, I kind of came up with this framework, but I think there is a lot more to be explored here. This is just my first draft, let's say, is my sketch, is the thing, it's the process that I am that I came up with. But I think there are probably many good ideas that I never came up with and that other people could come up with. That's mostly why I gave this talk, by the way, so that people can talk a bit more about it. Just to start this whole conversation. Let's see. Felipe says that when he rewrote the reloader, he really studied first all the code of Meteor that could affect the package. Wow, that's quite a thorough approach, Felipe. That's not one I have used, honestly. Let me see. Any other questions? Any other comments? +1 for a bunch of logs, +1 for trial and error. Thank you. Indeed, those are two very core parts of my own of my own debugging. Tea or coffee, asked Dimitri. Actually, I don't drink either of those. I tend to just drink water, and I'm here with a big bottle of water. I'm really, really boring when it gets to drinks. I don't like alcohol. I don't like tea. I don't like coffee. I don't like tereré. Sorry, Felipe. I don't like tereré. I have tried it several times. I live in Brazil, but tereré is not a favorite of mine. All right, thank you everyone for the comments and the questions. Jan has one more comment. Actually, create as much as possible on the server before startup and throw errors on top level. Sorry, Jan, I'm not sure what you mean by this. Sorry, I don't really understand it. Anyway, sorry, I think my time is starting to run out. Thank you very much, everyone. It was great to talk to you. I'm really happy that I got to talk to you all about this topic, which I think we should all talk a bit more about. And yeah, if you only remember one thing from my talk, let's talk more about how we debug. Thank you very much.